Hello, this is Marcus Egger. I'm the President and Chief Software Architect of Code Consulting and the entire Code Group. I am recording a brief AI executive briefing. I've recently done this presentation to a live audience with a lot of back and forth discussion. I wanted to record a shorter version of this, more condensed without the back and forth, just so we have something that can easily be shared as a follow-up item and amongst those that are interested. So let me switch over to my screen view so you can actually see my screen, and let's get started with the presentation. First of all, who are we? The Code Group is an organization that basically helps people build better software. We do so in a variety of ways, anything from training to consulting to strategic staff augmentation, we publish a magazine, we do a lot of different events. And in this particular presentation here, I want to share some of those things that we learn in our role that we play in this overall ecosystem. So we have a lot of contact with various customers. We do a lot of training. We have thousands and hundreds of thousands of magazine readers. And a lot of them send us a lot of information. So we know what works. We know what doesn't work, simply not because we are the greatest, but because we get a lot of information from the industry. Now, the topic at hand today is artificial intelligence, something we are intricately involved with, have been for years. But of course, in 2023, that is when this took off in particular. Okay, so let me get further forward here in our presentation. I already mentioned who I am, a little bit of additional information about me. I personally spend a lot of time speaking. I spend a lot of time writing. I do spend most of my time writing production code, but I also do a lot of teaching and presentations. I'm also Microsoft Regional Director. I do want to point out what that means because a lot of people always ask. Being a regional director means I have an official relationship with Microsoft, but I am not, and I want to be very clear on that, I'm not a Microsoft employee. So I can say whatever I want, and I usually do, and I'm not like peddling a Microsoft marketing message or anything like that. I do, however, have access to a lot of insider information about Microsoft stuff. Anyway, that's all I want to say about us. What are we talking about in this presentation here today? We want to talk about AI and its current capabilities. And I want to talk about this whole new paradigm that we're now getting into as part of the software industry, which is the paradigm of copilots. Microsoft is pushing that paradigm a lot, and you'll see that show up in all kinds of applications. So that's what this is all about. I'll show you some real-world examples. And then again, this is a re-recording of a real-world dialogue we had that was a back and forth, not just a monologue. This presentation is more of a monologue, obviously, but feel free to contact us with questions to turn it into a dialogue. So let's talk about AI. What is AI? In short terms, and I'm not going to linger too long on this, AI is about machines performing tasks that at least appear intelligent. And I want to be very clear on that right away. Machines today aren't truly intelligent, but they're doing a darn good job at simulating that they are. So that's very useful, even if it's not truly intelligent. It used to be just up until very recently, we would describe AI as something that's always just beyond our reach, which is a year or 2 years or 5 years away from truly useful artificial intelligence. In 2023, that has changed. We are now at a level of artificial intelligence that even a year ago, as I record this in November of 2023, even November of 2022, most of us would have considered everything I'm going to show you here today to be science fiction. Okay? So it's amazing what it does. Yet at the end of the day, and I want to stress that and be very clear about this, we are talking about mathematical models. We're talking about a lot of statistical math. We're talking about a lot of pattern matching, not true intelligence. So when we think of examples of computers being intelligent, we can go back in history to the 1950s and we'll find a lot of stuff. You know, just even finding data in large sets of data used to be considered intelligent. But more interesting is the ability to play things like chess, or more impressively Go, was something that we considered would take true human-like intelligence to beat a human at chess or Go. Well, this has now changed, even though we haven't achieved that true level of human intelligence. but machines are now routinely beating even the best Go players. In fact, just a little while back, a human managed to beat the best Go AI, and that was the newsworthy item. So the human occasionally beating the machine is now the amazing thing. A few years back, it would have been completely the opposite, and we considered it impossible for a computer to beat a human in a game as complex as Go. More importantly for us as business application developers, and especially in the medical industry, we want to do things that are useful in a business sense. That could be predicting patient outcomes, that could be analyzing patients' medical history, that could be visual and audio recordings and recognition. It could be the legal aspect, like dealing with insurance companies or other legal issues. It could also be translations, as we're dealing with people that speak different languages, and even on the side of the physicians, we have people that speak different languages and more comfortable with some than others. Now let's dream for a moment. Let's dream about a new world of medicine. Let's talk about a world of medicine where a young doctor in a hospital, perhaps on the night shift, gets called into a patient's room with a patient who has an emergency. The doctor has never seen that patient, yet walks in and needs to make a decision immediately in order to save the patient's life. That young doctor may be nervous, but that young doctor may also not have all the information that is needed. So how does one review a patient's medical history with all details and all factors that may need to be considered? How do we know allergies? How do we know cross interactions between medications? How do we know the more unusual aspects of this patient? And how do we quickly diagnose what the patient's problem is? Now, AI is not going to necessarily solve that, and we're certainly not at a level where we say the AI is going to treat the patient, but the AI could certainly present all the useful information, so the doctor now knows the patient has the following history, it's likely to be one of the following things, got to be careful with the following medications, he has a family history of whatever factors there might be, and thus can then be better armed at making the decision that needs to be made, probably in a matter of seconds or minutes. How about if that doctor could converse with that patient in whatever language that they need to be conversing? What if that patient, after the doctor is done with that patient, the doctor then moves on to the next hospital room or to the next patient, and then after doing all that, rather than spending more than half of the doctor's time on doing administrative tasks like documenting the cases that have happened, instead have an AI that helps with a vast majority of that task, that chore, so the doctor can actually focus on what a doctor wants to focus on, which is being a doctor and treating patients rather than doing secretarial type tasks and documenting the cases that happened. What if the doctor could then prescribe a certain treatment that needs to be cleared with the insurance company, yet the AI can help the doctor make a compelling case as to why a certain procedure or a certain medication is warranted or not? So I'm dreaming about a world like this. I'm not a physician myself. Maybe some of these things don't even make sense because I'm a computer guy. But you see where I'm getting at. A world in which something like that could be done, perhaps out in the field where we're in a rural scenario where a doctor doesn't have the information that another doctor may have, or perhaps we have a patient that has a very strange diagnosis, or we can't quite figure out what's wrong with the patient, and the doctor can't possibly consider all the different things that might be wrong and all the research that has been published on the symptoms the patient has. But an AI could then draw the doctor's attention to a very obscure fact that says, hey, I know you haven't considered this yet, but maybe you should look into that. Again, the AI wouldn't, in my view of the world, make an autonomous decision, but the AI would draw the doctor's attention to other possibilities if all else fails. So to me, that's a world worth dreaming of, yet it's not a dream. Everything that I've just told you is possible today. It is possible with the technology that we have today. That doesn't mean that technology has been rolled out and deployed, but from my point of view, from the technicians, from the software developers' point of view, from the engineers' point of view, everything I've just told you is not science fiction, it's science reality today, and we can make that happen. And in fact, I'm going to show you a very brief example that I've created. This is a trivial example. It's something that I've created ahead of doing this presentation. It's a pretty simple little application that, just for demonstration purposes, I've thrown together literally in the course of 15 or 20 minutes. And what I have here is a sample application that has some medical history for a patient. Now, this medical history for patient John Doe, of course, is all made up. And in the real world, we will probably have a much, much longer history. But that doesn't matter. It's technically the same thing. It's just as valid. And in here, we have all kinds of information about the patient's history, the illnesses, the surgical procedures the patient has had, the family history, with the father of coronary artery disease, and the parents apparently have been prone to breaking bones, and the mother had diabetes and so on, and then just other history, medications this patient was on, a history of checkups. And again, in the real world, all of this would be more detailed, but you get the idea. We have a patient's full medical history here. And now let's say the patient is in our hospital. We get some information directly from medical equipment, like what's the patient's current heart rate, what's the patient's blood pressure, what's the oxygen saturation, many more factors that in this simple example for illustration purposes I didn't include, but you get the idea. I'm simulating that we would be getting information from machines live and in real time. And now the patient had an emergency. I just walked into the room. I'm a doctor who's never seen this patient before, and I need to make a decision. And what I do here is I can put in the symptoms the patient has. In this case, the patient can't breathe and has severe chest pain to a point where the patient is not communicative. What could be wrong with this patient? And I'm clicking the Diagnose Emergency button, and this could be triggered in a real world in all kinds of ways. This could be integrated into systems the hospital already has. But however this happens, one way or another, we click this button and a diagnosis is created for me. Now, this is not meant to be the final diagnosis, but it's supposed to help me figure out what to do. So the system says, likely this patient has the following problem. We also know that the following vitals are currently a little bit strange: elevated blood pressure, elevated heart rate. Now we could change some of this. We could say, the heart rate has just gone up to, I don't know what makes sense, 195, and the oxygen saturations are dropped to 66%. And we click Diagnose again, and the AI now gets invoked. Now, I'm doing this for real. This is a sample, but the invocation of the artificial intelligence here, I'm doing this for real. This is a real artificial intelligence that responds behind the scenes. And so now it says, oh, wait a minute, the blood pressure, the heart rate is now much elevated, which may be a response to this infarction that the patient is experiencing. We also have critically low blood oxygen saturation if we're not immediately intervening, so that's important. And here's some other important information. Here are, based on the medical history, the different medications that this patient is taking that might be significant for the current problem. Not that these are all the medications, but these are the ones that are probably related or might be related, it's up to the physician to decide, to the current problem. And we also know that the patient has the following allergies that might be relevant. And we see that there's other history that might be relevant. Known family history of coronary artery disease, for instance. We know that the father had a coronary artery disease and passed away from it. The mother has diabetes and hypertension. What it doesn't list here is that there's a history of broken bones in the family, because that's not relevant for the current case. So it's a simple example, but it goes to show what an AI could do. It could show me in very quick ways what might be wrong with this patient. And it could do so perhaps in a more targeted way. It could say, this is for an inexperienced doctor who's nervous about his first few cases, or this is a very experienced surgeon, and she has different needs for different information because some of the stuff she doesn't need. Another thing I could do here is I could say I'm really more comfortable speaking German, and then I redo the diagnosis here. And now this doctor who is speaking German, who might be nervous and perhaps not do as well in English at that point, gets the same information in German, even though all the history, all our knowledge base, our institutional knowledge, our medical knowledge that lies behind this artificial intelligence that allows it to make this diagnosis. All of that is in English. I don't need to keep that in multiple languages, but the answer can still be given in this case in German, or I can, I had another example here just because it looks very different. I can also give the same diagnosis in Thai language, which even uses, as you'll see, the Sanskrit fonts, and I presume this is correct. I don't really speak Thai, but you get the idea. So this is just a very simple, quick example of something that we can not just dream about, but something that's available today. And again, this is something that I put together in literally less than an hour, far less than an hour probably, just to give you a first idea. But we could certainly take this a lot further in the world of medicine. Okay. Now, a lot of people look at this and say, is this dangerous? It could be dangerous in a variety of ways. It could be dangerous because it gives us the wrong information. And people have by now heard that sometimes AI hallucinates and gives the wrong answers. And that is a concern, but it's a concern we can manage. So if you are someone who's played around with various AI chatbots, you notice that they're often wrong. When we as software developers go out and create these things, we need to make sure that they are right, and we can do that by adding the appropriate information. It's a process called grounding, and then you actually get a much more reliable artificial intelligence. Now, one other thing I'm not going to spend a lot of time on, but people worry about other things like the singularity, which is, will AI become so smart that it'll eventually outsmart us and take over the world, and all that sort of stuff. The short answer is that is not a concern with what we're doing here. That may become a concern down the road, and we're probably talking 50 years down the road, but maybe I'm wrong and maybe it'll happen faster. But what is a fact is that the technology that we are employing today is not of the kind that could evolve to become smarter. That would be completely different technology. It's not like saying, we've had slow cars before and they got faster and faster and faster. And why couldn't AI that we have today get smarter and smarter and smarter, just like cars got faster and faster and faster? It is much more like saying a car will never fly. You need completely different technology for that. So it's not a concern for today's technology, and we could discuss in detail why that is and what the technical elements of that are, but it's just not going to do that. Today's AI isn't generally intelligent. It's not self-aware. It's not cunning. It doesn't appreciate humor. People talk about the alignment problem, which is the AI aligned with our goals? It doesn't have goals. That's a completely different, that is truly science fiction. What we are talking about today is running mathematical algorithms that are super sophisticated, but at the end of the day, it's a fancy calculator and it'll never develop its own goals or anything like that. So the concerns are more about the impacts on society, the impacts on jobs, and I'm one of the people that believes that this might be bigger than the Industrial Revolution ultimately. Yet the current generation of AI, now that we've rolled this out in production for quite a number of people, what we discover is it actually generates jobs. It doesn't remove jobs, because this level of AI makes things feasible that in the past we couldn't even dream of doing. It wouldn't have made sense to hire 1,000 people to do something that's a relatively small benefit. However, if you can hire one new person to deliver this benefit, it may well become worth it. And that's what we see, is that things are all of a sudden within reach that make it worth hire more people to do those tasks. That's what we experience. Now, a little bit of a side remark, AI and robotics. Robotics in medicine is important because we can do things like robotic surgeries and so on, but I want to make it very clear that we are much further along with the software side of AI than the robotic side of AI. So that'll probably be a future wave where robotics really takes off, but it's also much more expensive to create an army of robot surgeons than it is to roll out software that can be used by millions of doctors around the world. Because once you create software, once you roll it out in the cloud, you can give people access instantly to that around the world. It doesn't work like that with machines you have to build. So we talked about that. I'm going to move along here. Quick note on the important pillars of winning the AI game. In other words, what's important to be successful with AI. One of those is data, 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 and more data, and the ability to process that data by simply having enough computing power. And that's really what happened late last year in 2022 and 2023 that makes this revolution in AI we are experiencing possible. We now have massive data centers in the cloud that provide an enormous amount of computing power. And especially in our part of the world, as well as in Asia, we have a lot of access to data that can anonymously be used to train AIs. And that's key, having massive amounts of data that form patterns that we can compare against. And there's other aspects like the funding being available and having skilled people and a political environment that's supportive. But these first two pillars are really what, in my mind, from a technical viewpoint, is the most important. Want to add a little bit of recommended reading here. Several books that I really enjoyed. AI Superpowers is kind of the classic in our industry. Compares what the US and China are doing in AI compared to a lot of other nations. Superintelligence is a book that's much, much harder to read, as I will admit, so I would recommend it less than AI Superpowers. But this goes much about the dangers of AI. So probably the one I would read last. AI 2041 is very interesting. It's a book that is 10 chapters. Each chapter tackles a different type of AI and how it can be done. And it does so by first having a story, a novel-style short story about a scenario of the future, completely fictitious, but then it spends the second half of the chapter actually talking about what technology can be used to implement those types of AIs. So very, very easy to read, entertaining to read, and interesting. And then there's 1,000 Brains by Jeff Hawkins, who is the founder of Palm. Palm used to be the company that did the first mobile devices, Palm Pilot, and so on. So the predecessor to things like the iPhone. And he, at heart, or his passion is actually neuroscience. When he sold Palm, he went back to being a neuroscientist, and he researches the brain, the neocortex in particular, to see how it relates also to AI. And it's a surprisingly easy read and very, very interesting to read. That's the 4 books I normally recommend. Now, in this particular scenario, I also want to recommend The AI Revolution in Medicine. This book is written by people involved in the creation of ChatGPT, and in particular GPT-4, and talk about how it applies to medicine. And it's a surprisingly fascinating and easy read, even to somebody like me who's not in the medical industry. You can just read the prologue and the first chapter or two, and you'll already get the creative juices flowing. It's a very, very interesting read, and it's all about what's possible today and what's available now. So this is not at all science fiction. It's about concretely implemented technology. So let's talk about what we can do today. Today, we have what we call narrow learning, which is not generally intelligent. And what that means is a narrow AI performs a specific task. That task could be something like predicting cancer recurrence. It could be something like statistical analysis of likelihood of readmission of a patient into a hospital and how to improve those numbers. It could also be something like vision analysis, what's in an image, what's in an X-ray. It could be audio analysis, like logging what a doctor says and what's important out of that. Or it could be in general, just speaking in a sense of speaking the English language or any other language. In fact, that's what has made AI explode in 2023, is things like ChatGPT, which are based on what we call large language models, or LLMs. And their goal simply is to speak and appear to speak intelligently. Now, that has some implications that we'll talk about, but that is really what A is in itself very interesting, and B also ties a lot of the current developments together. So none of this is truly intelligent. Nevertheless, it does a very good job at faking it, to a point where some people even say, well, maybe that's just all the human brain does, so maybe there's something to that, I don't know. Bottom line is the results we can achieve through that are just extremely interesting. Now, when we talk about a lot of that, one company name comes up, and that is OpenAI. OpenAI is the company behind ChatGPT. I want to tell you a little bit about them because they're very important in our industry. There's really two different OpenAIs. One is OpenAI Incorporated, founded in 2015 in San Francisco by, I believe, about a dozen founders, which is a nonprofit dedicated to developing artificial intelligence. They then founded OpenAI Limited Partnership, which is a for-profit organization, 49% of which is owned by the original founders, to my knowledge. 2% is owned by the original OpenAI Incorporated nonprofit organization, and the other 49% is owned by Microsoft. So Microsoft has a big involvement in OpenAI at this point. When I created this slide, I said they invested $11 billion in OpenAI. I think at this point it's not totally announced, but I think they're around $13 billion. So they plus OpenAI Incorporated, the nonprofit part, control 51% of what's OpenAI, which is why often people say OpenAI largely is Microsoft. It's not totally true, but it's kind of become that way. And all of OpenAI's technological infrastructure runs on top of Microsoft data centers, runs on Microsoft Azure, the Microsoft Cloud. And in reality, the investment that Microsoft's making into OpenAI, a lot of those 11 to $13 billion are letting OpenAI run on Microsoft infrastructure, which is very, very expensive. We can talk about that right away too. Running AI at this level is a massive undertaking. It's not something that most companies can do, and certainly not private individuals. And so that's how Microsoft funds OpenAI. And there's stories out there about OpenAI running out of money because they lose so much money and all that, which is true. They lose a lot of money, but it's funny money. It's basically Microsoft supports them. And even though they run up a huge tab, that's just Microsoft supporting them. And it's not literally that they'll have to pay Microsoft for that. It's Microsoft's investment. OpenAI owns a number of different technologies. One of them is what almost everybody has heard of, ChatGPT. If you go to chat.openai.com, you will find a chatbot, but it's not a chatbot of old that is kind of very limited, but it is a chatbot that allows you to interact with it as if it was a human being, and you'd be hard-pressed to know the difference if you can at all. Now, what this is essentially a technology demo. This is not the end-all, be-all of what OpenAI wants to do, but it's a demo of their GPT technology that runs behind the scenes. And without telling you too much about that, the point is that this same technology will be used going forward, and it's already used today, to build a modern generation of software that goes way beyond what we've seen in software in the past. Since the 1950s, all of us software developers, well, most of us don't remember this far back, so all of our careers we've spent building software in a certain way. Now that way has evolved, but it's been based on the same ideas. We write programs that run and execute exactly what we want. This has now changed to having an artificial intelligence behind the scenes, where we don't tell it step by step what we want to do, but we just tell it the result we want, and it kind of comes up with it. And that's the big paradigm shift that none of us in our industry have ever seen before. And it's a little fuzzier than in the past, but it's tremendously more powerful. And that's why we all believe that this will be the basis of modern software going forward. It's a paradigm shift like none of us have ever seen in the software industry. Okay. Now, OpenAI is not just ChatGPT. AI is not just about GPT. There's many different pieces of AI. I've already told you about things like analyzing X-rays visually, or I have a sample that does retina image analysis. There's statistical prediction, recurrence, and financial predictions, and all kinds of stuff. Those are different kinds of AIs. But what's interesting about GPT is that GPT makes it easier to compose larger AIs out of smaller pieces. In the past, the classic problem in AI development was that once you had an AI, it was very difficult for users to use it and expensive to create something around it that enabled us to use it well. We've now started integrating AI more and more into these language-based AIs. And now all of a sudden they become very, very usable. So the technological details are probably not that important. I'm happy if somebody wants to reach out to me to discuss that. But just this general idea of building AIs composed out of smaller AIs is really, really interesting. Now, Microsoft is doing some really interesting things now that they have this partnership and ownership of OpenAI. In fact, when GPT 3.5 in November of 2022 and GPT-4 earlier in 2023 came out, Microsoft completely pivoted. And I've worked with Microsoft for 30 years. I've even worked at Microsoft for a while as a contractor to some of the development departments. I've never seen Microsoft do what they did right now. Microsoft's fiscal year starts in the summer, and that's when the plan is made for the next year. Microsoft sticks to this plan. Not so this year. In January of 2023, Microsoft completely abandoned all their goals and plans for 2023 and instead pivoted towards AI. And there now is a paradigm within Microsoft where every Microsoft product has to have an AI story. And this all is done under one shared brand, which is Microsoft Copilot. Microsoft Copilot is something that appears more and more in various products. Anything from Bing search to the Microsoft Edge browser has it integrated, to Microsoft Office products. We're now in November of 2023, and Microsoft has started to roll out in production their Copilot within Office. And what this allows you to do is something like you could attend a Teams meeting. You show up late for that meeting, so the other people were already talking about stuff for a half hour. You then show up in the Teams meeting and you ask Copilot, you say, hey, what did I miss? And Copilot is smart enough to analyze the spoken word that happened in that meeting and then give you a text description of here are the so many, maybe 5 most important points that you have missed. Then you listen to the meeting, then the meeting ends, and then you say, okay, but what are the most important decisions we've made? And Copilot gives you a list of decisions. Well, maybe those are to-do items. You can then tell Copilot, okay, put it into my to-do app of whatever app I'm using. And then maybe you add some other stuff because it's not autonomous. It's just there to assist you. So you can always tweak what it does and add yourself, or go back to doing it the old-fashioned way. If you want to add 5 more items to your to-do list, you can still do that. Nobody takes that away from you. And then you say, okay, but one of the to-do items was we agreed that we had to do a quote for a customer. So let's start a Word document based on the things we discussed, and then Copilot creates a Word document. And then you add to it yourself and manipulate it and change it, or ask Copilot to redo certain parts. You add your own sections to it. Then you say, hey, Copilot, I need more information about the product we are selling. Put in the most important parts and some product images, and it does that, and then you tweak that. And so you go through, you create your document like that, and then you say, hey, Copilot, I need a PowerPoint presentation that is a good visual style for this target audience, and create that for me with the most important points. You tweak it, and you have a good PowerPoint presentation. And this all sounds like, yeah, that's a demo, and it's not really going to work for me. The amazing part is how well it works. And this will work for you. And Microsoft's now building this into all its products, from Office, or M365, I should say, to Windows itself will have a Copilot. In fact, my Windows already has one. To the Edge browser, software developers use it, but that's a little bit of a special case. And that's the new paradigm that we are now getting into. Here's an example of the Copilot in the Microsoft Edge browser. So if you're still using Chrome, might want to consider trying out Edge. because it has this Copilot built in and you can ask it amazing questions, which totally changes your web usage paradigm to rather than searching for stuff, you're given answers. So in this particular example here, I'm a United frequent flyer. And so I said, hey, what does it take to reach a certain level as a United frequent flyer? Or how do I use bonus points or anything like that? Normally, I would now get a number of documents, which I can then click into and read and find my own answer. And I read through them, and then hopefully I piece it together. With Copilot, it does all of that for you and then gives you one coherent answer. And the difference between this and ChatGPT is that this is factual. It doesn't just answer questions based on being able to talk the English language or any other language, but it retrieves the appropriate documents and then answers the questions based on those documents. So a fundamentally different paradigm. This doesn't hallucinate. This doesn't give you wrong answers. Or very, very rarely, it's, the web may serve up wrong answers too. So if it's, victim to that problem. But in general, this is much more reliable. And when you think of this, a step further, now we think of medical scenarios like our patient diagnosis. That's what we need to do in that as well. Rather than just giving answers willy-nilly, we need to have it based on very specific things like the medical history, certain research papers we trust, whatever it is we consider a source of truth, rather than just answering. And I already told you in the past that these AIs have a narrow purpose. All of these language AIs, all of these spoken word, give me an answer type of AIs, their goal, their narrow purpose is to talk and appear to be thinking. Their purpose is not, and I want to be very clear on that, their purpose is not to be a knowledge base. That was never a goal. So people go into things like ChatGPT, ask it questions, and then sometimes they get the right answer and sometimes they don't. Well, that's by design. These AIs are not truthful. That was never a goal of these AIs. They do know an amazing amount of stuff, which is great, but that's almost like a coincidental side effect, because the way you teach them to speak involves all kinds of information which they can then regurgitate. But to truly be useful in a business scenario or in a medical scenario, we need to make it truthful. That's our goal. We need to tell it what a source of truth is, what a knowledge base is that can be used, and then answer the question grounded in that reality. And then you'll find a much, much more reliable answer. Perhaps still a little fuzzy, not right 100% of the time, but certainly much, much more right than even the best human expert, because it can consider so many sources. No human expert can memorize millions of research papers, for instance. The AI can. So that's what we are aiming for. Now, to give you an idea of what it takes to do some of this stuff, because a lot of people then come to me and say, oh, well, let's train our own AIs. And you don't do that. These AIs are massive. They take months and months to train. They take hundreds of millions of dollars to do so. And to give you an idea of that, here is a photo of the Microsoft Azure data center in Dublin that I believe was just finished. And if you look at the cars, the trucks, the people, the pieces of machinery, the cranes in this image, the trees, you get a sense of the scale of how big this thing really is, because the picture doesn't do it quite justice. The data center that Microsoft has in Dublin, they have a space on the roof for this data center that's 1 mile long and half a mile wide. That's the scale at which we're talking about. But it actually gets a little worse, because Microsoft doesn't add just one more data center like this. Microsoft's been building these data centers. They have plans for 150 data centers they're building around the world in 18 months. Now, I think this effort has started about a half a year ago, so we have 12 months left. And currently, data centers like this one are coming online and are being finished at a rate of 2 to 3 a week. Or, in other words, every 2 to 3 days, a new data center of this scale is being finished. Now, let that sink in for a moment. That's the scale at which we're talking about. And that is required to run these AIs, because it's all so computationally intensive. Now, there's obvious environmental concerns around that, and I think Microsoft's trying to do a really good job at this. Aiming to be carbon neutral by 2030, aiming to be carbon negative by 2050, where they promise to take all the carbon the company has ever put into the air back out off the air, including all travel and other activities. Whether they can do that or not, I don't know, but at least that's the goal, which is nice to know. And Microsoft being repeatedly voted one of the most, or the most ethical company in America, I do believe that they are sincere about this goal, but we'll see. Anyway, so what we are seeing as a bottom line for all of this is that applications that do not have these features are now legacy. They will very quickly become old. This will very quickly give people the chance to leapfrog older apps. I think it'll also, and this is kind of interesting in a medical environment, I think there's great opportunity to improve things for the better. I think there's great opportunity to not miss things, if you want to think of it that way. I think eventually there'll also be some liability around missing that opportunity, perhaps. So that's something to think about. But that's kind of what we are looking at. Now, let me show you another example that we have here. And let me open up an application that we use in-house within my own organization. So the code group does a number of things. We have a staffing arm where we employ a lot of people. We have a consulting arm. We have a training arm where we schedule training classes. We publish a magazine that's a print publication. And so we need to manage all of that. And I'm going to show you a little bit about our own application here, just so you see some of the things that we are doing. Now, this has nothing to do with medical, but you can probably extrapolate from there and see the characteristics of how some of these applications work today. So what we are looking at here is my development environment. So for those of you who are not technically inclined, just bear with me. I'm showing you kind of how the sausage is made here. So here is our application. We'll start that up. It's a Windows application, typical business app. And one of the things I can do in here is I can go into a database of articles. And so I can go in here and I can look at articles by, different, could search for articles, look at different issues of the magazine, or in this case, I did a search by author. And so I could go in here and I could look at different things that this particular author has written, and we could now drill into this and find an article that we are interested in. I'm just going to pick one here. We could open that up. And in this article, we have some interesting things. We have the actual article content that the author wrote for us with a preview, how it would appear in print or online. And we could click to see that article online. And here is that article on our website for people to read. So that's something we publish and we manage in here. And you could search for this on our website. And when you search for it, it'll bring up a list, and the list will have a brief abstract with the article. It'll say, here's the article title, and here's the article, the abstract, like what's this article about, and says, oh, it's the July-August 06 editorial, so older article that I happen to pick here. But we can see the abstract is really not very good. And in the past, we didn't create better abstracts because it's expensive. I needed to have a very technical person read through the article, then come up with an abstract, and it goes to a copy editor who has to make sure that the abstract reads right. What we do now instead is we just click this button and say generate abstract, which causes an AI to go and read through the article, understand the meaning of the article, and then create a summary, a short abstract that we can now use for web searches that's more suitable than the one we had. So that's kind of interesting. And this gives you an idea that an AI doesn't always need to be something where you type a question and then it answers. It might just be a simple button click. But I could also open up a more conventional Copilot here. Now we have this Copilot pane on the side. And this is a good example again of how we can integrate Copilots into all applications. Like I said, applications without Copilot are now legacy apps. And so I could come in here and I could now do interesting things. And to make my demo as short as possible, I'm going to get to it. I'm going to do something like this. Do we have any articles in our database that are similar to this article? Please provide a list. Now that's very interesting. Again, the behind the scenes stuff here we're not interested in. It's interesting because in order to answer this question that I just asked it, it has to comprehend the content of the current article in a meaningful way, and it then has to go out and comprehend that A, it needs to search for articles, and B, it needs to then read all other articles that we have and understand that they are similar in content. And let's try that again without the behind the scenes stuff popping up. Okay, let's see if this produces anything. I guess we're not connected to the database right now, so I'm sorry, my sample is not very good. People that attended this class for real saw how this works. But just that fundamental idea of being able to do this, and I believe I have a screenshot of something like this somewhere that I can show you. Here's a similar scenario. What we do here is, this is an application that has a very similar basic idea, right? It has a knowledge base of articles, and we then ask it questions, and I'm going to start with the simple version here. Okay, so in this case, we ask it a question like, this is about not medical stuff, but you can imagine this is medical stuff. We have a database of documents that in this case relate to a homeowners association. In fact, it relates to hundreds of homeowners associations because this customer is an umbrella organization for homeowners associations. But again, this could be medical documents, research papers. It really doesn't matter for us from a technical point of view. And we now ask a question, like in this case, the question was, when is the pool open? And it searched for through all the documents we had to ground this information in, retrieve the information, and then give an answer. Now, to give this answer, a few very interesting things had to happen. First of all, it had to know that you have the rights to do so. AI still needs to be secure, especially in a medical environment. It needs to be secure, needs to be compliant with things like HIPAA and other standards that we have to comply with, or regulations. So that's one thing, security and regulation compliance. It then has to understand fundamentally who you are. It's not good enough to just answer when any pool is open. You could ask ChatGPT when pools are open, and it will probably say, well, in general, pools are open in the summer. Well, that's not good enough here. So we need to ground this information, the answer, in the knowledge base that we have, the institutional knowledge that we collected here. So for that, it has to know, where do you live, what neighborhood are you in, and then, okay, in your neighborhood, the rules for the pools and the open hours and so on are this. So it comes up with an answer. It also provides a list of source documents. When we look here, it tells us, okay, we had hundreds of thousands of documents. Out of those, these documents were actually part of creating this answer that we had up here. We may have had 500 documents that related to the pools in our neighborhood, but these were useful for answering this question. And then it even suggests interesting follow-up questions, right? So in a medical scenario, you can imagine that you ask for a diagnosis or various things, and it would then say, well, here's the answer that I think is correct, or here's some more stuff that you should look into, because most of the time, you don't want it to create the answer for you. You just want it to make it easier for you to then make a decision. And it then lists the research papers or your internal procedures or whatever might be useful to answering that question. And then it suggests certain follow-up questions. So it might say, well, you have this patient here with these symptoms. These research papers might be useful, and therefore I think this is what the answer is, but go ahead and click through it to see more details. But also, because of the symptoms this patient has, maybe he took a very unusual medication. Maybe a good follow-up question would be to say, well, what else do we know about this medication, and are there any drug interactions or anything like that? Or, of course, you could go into the text box and you could add your own additional questions based on the information that's now available. So in short, security, compliance, logic, understanding of specific situations, is all very important in this kind of AI to give a reliable answer that's useful for people like doctors. Now, here's another example that I find fascinating. In this case, we're using the same knowledge base. It's all based on English. The entire institutional knowledge for this organization is kept in English. The data records, which by the way are also integrated, this is not just about a static list of documents, but we are talking about certain data records. We're talking about live real-time data. So things that might come from medical equipment like heart rate monitors and all kinds of other stuff could directly feed into this. So we're not just talking about documents, but we are also talking in these sophisticated scenarios about potentially streaming data or very up-to-date data out of all kinds of data sources. So all of that in this particular case is kept in English. Yet, as you can see here, I asked it a German language question. It then understood that even though it was German, it had to search in the knowledge base based on an English search term. It then came up with matching documents to answer the question. It then answered the question in the language that it was originally asked. Now, how is this done? Well, there's some secret sauce to it. And this has been a tremendous benefit we've been able to extend to our customers, because just imagine, language is now not a hurdle anymore. How big a step is just that? And then again, it shows the source documents and it does things like suggest follow-up questions. And again, the follow-up questions are contextually meaningful and sensible. And in this case, in the language that the user wanted to interact with. Now, people usually ask, what languages does this support? The answer is all languages that are found on the internet, because that's what these intelligences are being trained on. So if you want to speak some kind of obscure language or even a dialect of an obscure language, it will probably support it. Now, it does a little better with languages that have a lot of information on the internet, like English or French, German. You got the Chinese languages like Mandarin, the Indian languages, Spanish, all that sort of stuff is very, very, very well supported. But you can go with a relatively obscure language and it will still do a pretty darn good job at interacting with you. And, that's to me tremendous, both in terms of, say, medical professionals that have a different language as their mother tongue. It's also very interesting because as a doctor, I could say, well, give this patient some information. Hey, AI, pull together some information about some of the things that I just recommended and further reading. And then I look at it and it's all in English. And then I say, okay, well, now send it to a patient in email, but send it in Portuguese, for instance, because that patient's first language is Portuguese. So those types of things that break down the language barrier, to me, are just tremendous. So that is the short version of a discussion that ended up going pretty lengthy when I did it in person, where it was much of a dialogue. Again, I invite you to be contacting us to make it a dialogue. Send me your requests, marcus@codemag.com, info@codemag.com. Probably gets you a quicker answer because I'm usually behind in my email reading. But I will promise we'll get back to you. We're not the kind of company that charges you for a 15-minute email answer or a dialogue on the phone or something like that. Be very, very happy to help you out. This is a fascinating topic. I'd love to hear about ideas people have around this, because I'm fascinated as we are building these AIs, what people are using them for. There's literally, I can't think of a single scenario, and I've talked to a lot of customers and in the community, and I have yet to see a scenario where you say, oh yeah, AI can't do anything here. It's literally everywhere, and it's fascinating. I'm having the time of my life. After being a company owner for 30 years, this is by far the greatest time in terms of being a software developer. I'm having a ton of fun. And I'm hoping I got the creative juices flowing here. I'd love to hear what your questions are, what your ideas are. And with that, I'll end the recording. Thank you very much. I hope you enjoyed this.